Okay, welcome to another video. Today we're going to solve Physics Paper 1, October November 2021, Variant 1. So let's start with question number 1. It says, which quantity is a vector quantity? So as you know that the scalars and the vectors, scalar quantities are the quantities which has a magnitude, while quantities are the quantities which has a magnitude as well as direction. Therefore, we're going to choose the quantity which is going to have a direction as well. So there is a force which is going to be the vector quantity. Otherwise, speed is a scalar, mass is a scalar, and distance is a scalar. Two forces x and y, x upon an object with the arrow, right? So which arrow shows the resultant force? Now you will apply head to tail rule for this. So for head to tail, I'm going to take this vector to this side, and the resultant will be like this, and direction will be like this. So this is this arrow. So two identical objects begin to fall from the rest. One object falls from 200 meters above that Earth's surface. Other object falls 200 meters above the Moon's surface. 1 second after they have started to fall, both objects are still accelerating. There is no atmosphere on the Moon. The weight of each object is constant, which will describe the motion of the both objects at this time. So, since they both are accelerating, the acceleration of the object falling above the Earth's surface that has to decrease because there is an atmosphere on the Earth, and since there is no atmosphere on the Moon, so that has to stay constant. So it is decrease and constant because on the Earth, air will push this upward, so the resultant force will decrease. The diagram shows a car going around a circular track at a constant speed, which arrow shows the direction of the force, resultant force on the car. So it is centripetal force always towards the center of circle. So circle center is somewhere here, so it will always be towards that. An electron has a mass. Where does the stationary electron experience force? So it is going to be electrical field only. No, it should have a gravitational field as well. Gravitational field and electrical field only. Yes, it's not going to experience any force on magnetic field since whenever electron moves perpendicular to the magnetic field, then it experiences force. Here it does not say any kind of this thing. So for the gravitational field, since electron will have some mass, so therefore it will experience some gravitational force. So it's going to be C. A stone is placed in a measuring cylinder of water as shown in this. The reading is 75. The volume of the water in the cylinder before adding the stone is 15. So the stone's volume will be equals to 75 minus 15, that is equals to 60. The stone has a mass 90 gram. What is the density? So density is equals to mass over volume. So mass is 90 and volume is 60. So it is going to be 1.5. The extension of the spring is measured for the various loads. The limit of proportionality is not reached. This graph shows the extension and the load graph of the spring. It will be a straight line because its limit of proportionality is not reached. So it should be straight line passing through the center because they are directly proportional to each other. An underwater diver moves from the ocean into the fresh lake. The density of the water in the lake is less than that of an ocean. In which position does the diver experience the smallest pressure due to the water? Since the density will be of the lake is smaller, therefore the pressure will be lower on these 2 points. So we need to select now other 2 points. Since this point has more depth, so this is going to experience more force, but more pressure. This is a less, just this will experience a lesser force, or sorry, lesser pressure. Air is trapped in a cylinder by the piston. The pressure of the air is P. The length of the air column is 20. The piston moves outward. The length of the air column is increased by 40. So the temperature is constant with the new pressure. So first of all, you will take this length as a volume because the area is constant. So therefore, the area times height is going to be the volume. So let's take this as area as A. So P1 V1 is equals to P2 V2. When it was 20 times A, this is the volume. The pressure was small p. Now we need to find out the new pressure when the volume is 60 times A. So this is going to go and divide here. So it is going to be P 20A over 60A. AA gets eliminated. So this is P over 3. So 9B is your answer. When a pressure is exerted by the atmosphere is 0.1 megapascals, the height of the mercury barometer is 0.76. What is the pressure exerted by the atmosphere when the height of the mercury in a simple barometer is 0. This. So first of all, let's find out the density first. Since the pressure of atmospheric pressure was given, which is 0.1 into 10 to the power of 6, and density is unknown, G is 10 and height was 0.76. So let's use our calculator and see what is going to be the density for this. So it is this divided by 10 divided by 0.76. So this is your density 13157. Now I'm going to up times it with 10 and times it with 0.57. So this has to multiply with 10 and then 0.57. So the answer is 75,000. So it is 0.075 megapascals. Because 75,000 is when you need to take it decimal 6 times backward, 3, 4, 5, 6. So it is going to be 0.075 into 10 to the power of 6. This is mega. The diagram shows the block of mass m is pulled in a straight line along a horizontal surface by the force F. The block moves a distance d in a time t. The average speed of the block is v, which two quantities must be known to calculate the work done. So that's easy. It has to be the force and the distance d, because work done as a formula, work done is equal to force times distance. In question number 12, it says the diagram shows the inside of a refrigerator. When the refrigerator is first switched on, what happens to the air near the cooling unit? So that air near the cooling unit will move closer. It cannot become smaller air molecules. It can either move closer or it can move away. They move closer since they are cooling down, right? And the density of the air has to increase because when they cool down, they become more denser and they drop. They just settle down. This sink. Less thermal energy is needed to raise the temperature of 1 kg of copper by 1 degree Celsius than needed to raise the temperature of 1 kg of water by this. Which statement explains this? So copper has a lower specific heat capacity because this whole definition is of heat capacity. Wax has a mass 200 gram. Thermal energy is supplied to the wax at a constant rate of this per minute. What is the specific rate of fusion? So E is equals to MLF. E is 12,000. How many minutes are there? It started from 3, it ended at 7, so it's 4 minutes. So 12,000 times 4 is going to be your energy, and mass is 200, and LF we need to find out. So it is going to be 40. 12,000 times 4 divided by 200. So it's 240. So that is your answer. Just give me a second. Let me put my choice. It's off. Okay. So in question number 15, a fixed amount of gas is trapped inside a metal can. The temperature of the gas decreases by the volume, but volume does not change. Okay, temperature decreases, but volume does not change. How does this affect the kinetic energy of the gas and pressure inside the metal can? Since the volume is not changing, so it means uh, the, and the pressure temperature of the gas is decreasing. So it means the pressure has to be directly proportional with the temperature, right? So pressure has to decrease. So therefore, it is either A or it is C. Since temperature is decreasing, that is average kinetic energy of the molecules that has to decrease as well. So it is A. The diagram shows the room temperature of the liquid in the beaker. What reduces the loss of liquid by evaporation? Blowing air across the top of the beaker, that is going to increase. That's not going to reduce it. Heat the liquid, that will also increase. Put the lid on the beaker, yes, that will decrease. Transferring the liquid to the beaker with a larger diameter, that will also increase, that will not decrease. So only one thing which is going to decrease the evaporation. A water wave on a pond passes into the region where the wave travels more slowly, and then it returns to the region where it travels to the original speed, assuming that the frequency of the wave stays the constant, which is a side view. So, first of all, since speed is changing, so therefore the wavelength has to change. First of all, uh, it is traveling slowly, then it one passes to the region where the wave travels more slowly, and then returns to the region where it travels with the original speed. Then is okay. So it is going to be A because this is slowly, then its original speed, and then slowly. What is meant by the amplitude of the wave? 17. I think so. It has to say that, like, if the water wave on the pond passes into the region where the wave travels more slowly. So first of all, it was normal. Then it travels slowly. So therefore, the wavelength has to decrease, and then it comes to normal again. The wavelength increases. So that's why it's saying. What is meant by the amplitude of the wave? It is the displacement. So we need to check it. distance between the extreme point of the particle's motion. No, that's not. Maximum distance a particle moves from its equilibrium position. Yes. So it is going to be B because this is the equilibrium position. So this is the maximum distance from equilibrium position. So that's an amplitude. The diagram shows one of the wavelength of the wave as it travels from the deeper to shallow medium. What happens to the wave front as it moves into the shallow medium? You need to remember one thing: whenever the wave travels from deep to shallow, its speed decreases, wavelength decreases, but frequency remains the same. What happens to the wavefront? Its speed of wavefront decreases. The ray of light passes through the glass block, then travels through the glass block, then emerges into the air. What angle? What is which angle is the angle of refraction at the surface x y? So that has to be d. This is the angle of incidence for that, and this is the angle of refraction. Two rays of light passes through the lens in a region x. Which type of lens is region X? It has to be diverging because rather than by going straight, it is diverging. So it has to be diverging. And it always forms an image when you're going to backtrack this. It's going to form an upright image, and upright image is always virtual. So it is a virtual and diverging. Whenever, remember one thing, whenever your image is inverted, that is a real image. Whenever your image is a upright one, so that is going to be a virtual. A girl is a long-sighted. Which statement is correct? She sees a close object less clearly than the person with the normal eye. Yes. She sees a distant object more clearly. No. The fault is corrected by diverging lens. No, that has to be corrected by converging lens because the it focuses after retina. So a converging lens will focus it on the retina. The image of the close object is formed in front of a retina. It is no. It is formed after retina. So it is going to be A. A ray of light deviated by the prism, the angle of deviation measured by the light from the different frequencies include the D light and red light. Which graph D against frequency is correct? So first of all, the angle of deviation, you need to remember one thing. Whenever it is a prism and it splits the light, this is red and this is violet. So the angle of deviation of red is less than that of violet. So violet has a more angle of deviation, so blue has a more angle of deviation. And you should also remember one thing, red has the greatest wavelength, frequency is the smallest one. So the red will have a smallest frequency but greater, less, smallest frequency and smallest angle of deviation. So that is going to be D. Which component of electromagnetic spectrum is used for the remote control? This is always infrared. A student stands X in front of a large wall. He claps his hand at a regular rate so that each clap coincides with that echo from the previous clap. And in the time t, he claps his hands n times, which expression used to calculate the speed of the sound in the air. So it is 2x over t. Since we have to clap it n times, so we're going to make it at 2nx over t. The ultrasound scanner produces an image of an unborn baby. What does the scanner uses to form an image of a baby? So ultrasound will be reflected to by the baby, because if it is going to be absorbed, how can it form an image? Because if it is not going to be received back by the receiver, so how can it tell you about the shape of the baby? It's an it's a sound. It's not light, so it cannot give you a shape. It is going to give you the pulses that is going to be used to form a shape. Uh, an object X in a tool, the object Y is held above the X. The reading of the balance increases when Y is moved closer to X. Why does this happen? So if Y is moved closer to X, this if this is going to repel this, it is going to apply more force, so the balance reading will increase. So it means a repulsion. So this can be a magnet, yes. So X and Y are both a piece of iron. No, X and Y are both magnet. Can be one of the ones. X Y is a magnet and X is a piece of iron. No, then it has to be attracted by Y, and the reading should decrease. Y is made up of iron and X is a magnet again. The reading has to decrease. It should not increase. So only B is the right answer. Teacher wants to demagnetize a bar magnet and tries three different methods. Number one, heat the magnet to high temperature and then allow to cool. Place the magnet bar east to west and hammer it. Place a bar magnet inside the coil that has a direct current in it and remove it to, from the coil slowly. It should have an alternate current, not direct current. So that is wrong. Third one is wrong. 1 and 2 is correct. Piece of paper torn out of a exercise book is shown. Dash is a work done measured in joules on unit charge measured in coulombs as it moves around a circuit. So that is EMF. This is the definition of EMF. EMF is a work done on a unit charge as it moves around a complete circuit. Which circuit is connected to measure the current in the fixed resistor and potential difference across the same resistor? Okay. Measure the current. The fixed, so ammeter can be placed anywhere, but it should be in series. Voltmeter uh, across a fixed resistor. Yeah, that's correct. Voltmeter cannot be in series. Voltmeter cannot be in series. Voltmeter cannot be across two components, since we are measuring for one component. So it is A. The diagram shows a circuit of the 5-volt power supply, 3 resistors and 4 output terminals P, Q, R, S. Between which pairs of the terminal is there potential difference of 1.5 volt? Okay. So first of all, since we need to find out the combined resistance, that is going to be 10 ohm, and the voltage is there, so we need to find out current now. V is equals to IR. V is 5, I and 10 has to be divided, so it's 0.5 amperes. This is the current. So now I'm going to check out whether this is going to give me the same V is equal to IR. So I is 0.1, resistance is 2, so that is 1. It says 1.5, so PQ is wrong. So 0.5 times 5, that is going to give me 2.5, so that is also wrong, not a Q and R. So 0.5 times 3 is going to be 1.5. Yeah, that's correct. It is between R and S. How much electrical energy is supplied by the main when the switch is closed for 36 minutes? So if it is closed for 36 minutes, uh, we're going to apply the formula E is equals to P E. Power is 100 watts. Time is 36 seconds. So 30, oh, it's in kilowatt hours. So we need to make it a kilowatt. So it's 1 0.1, and this is 36 over 60. So that is going to be 6 over 10, which is equal to 0.6. So 0.1 times 0.6, let me see, 0.1 times 0.6, that is 0.06. This is for one uh, bulb, right? Since we have two bulbs, so we will add them together, so that's going to be 0.12. Cost of electricity is 9 cents per kilowatt hour. It takes 0.06 and cost 1.2 cells to boil of water in the kettle. What is the power rating in the kettle? That's easy. So 1.2 cent means, let's see, if it has 9 cents per 1 kilowatt hour, what is going to be 1.2 cell in kilowatt hour? So that's going to be 9x is equals to 1.2. So x is equals to 1.2 over 9. You can use mathematical ratio for this, right? I've used that. You can use other method if you know unitary method, divided by 9. So this is your, um, you can say, kilowatt hours that are in this. So what we need to do is we need to take up, so we need to divide this by time, which is 0.06. So that is 2.2. Okay, a transformer with an efficiency of 100% has a primary voltage input of 600 volts, a secondary voltage output of 240 volts. A secondary coil is attached to a resistor, resistance 120 ohm. Uh, what is the power distributed in the resistor? What is the current in the primary coil? So power on in the secondary coil is always equals to power in the primary coil. So let's calculate power in the secondary coil, which is equals to P is equals to V square over R. So that is 240 times 240 over 120. So that is going to be 480. So either it is C or D, A and B is wrong. Now we need to check out the current here. Since the power AP is equal to VI, power is 480, voltage is 600, I we need to know 6 equals to I. So that is going to be 8 and 10 and 0.8. So C is your answer. The diagram shows an alarm system in which switch S is closed. The top of the circuit is arranged so that magnet is positioned over a soft iron contact. What happens when the switch S is open? When switch S will open, this electromagnet will leave this iron contact. It will drop. So it will drop, and this will join this metal contact will close. So this bell will start ringing. So it rings. Microphone detects a sound, uh, and a signal is fed into a oscilloscope. The diagram shows the phase spotlight of the light. Oscilloscope takes 1.2 milliseconds to travel across the screen. What is the frequency? So first of all, there are two waves in 1.2 milliseconds. So for one wave, it is going to be 0.6 milliseconds. Milli is 10 to the power of minus 3 seconds. So this is the time period. Frequency is 1 over t. So this is 1 over 0.6 times 10 to the power of minus 3. So that is going to be 1000 over 0.6. So 1000 divided by 0.6. So that is almost 1700 hertz. Under which condition is the voltage across a fixed resistor the greatest? Fixed resistor, right? So it means here resistance should be minimum and here resistance should be minimum, right? So it should be, because they both have inversely proportional. Like this is LDR. In this, if the brightness is more, the resistance is less. So therefore, it should be bright. And here, if it is warmer, then it is going to be a less resistance. Technetium 99M is a radioactive isotope used in medical scanning. It is injected into the body and its emission are detected outside the body. What are the characteristics of technetium? Technetium 99M make it suitable for the use of the medical scanning. Uh, it should not emit alpha. It should emit a gamma, right? So first of all, we need to that, and it has to have a shorter half-life because if it's going to have a longer half-life, it will stay into the body and it's going to cause damage to that. The statement about the production of electricity in the nuclear power station is correct. The reactor, the main reaction occurs when the protons move. It's when neutron hits. The process takes place in the reactor that is called nuclear fusion or its fission. The reactor produces energy to boil water and to produce steam. Yes, it is a process. Carbon has a major waste. It does not produce any waste. It has a nuclear waste. It doesn't have any environmental waste. So in 40 it says that's very simple. It says what is this? This is electron and what is a Y? Y is a nucleus. So that's it. Hope you learned something. If I made any mistake, I'm pardoned for that. Pardon me for that, please, because this is a live video, so I can make mistakes while solving it. Thank you for watching this video.